Today, we'll be solving LeetCode 226, Invert Binary Tree. Let's walk through the problem together and learn how to solve it step by step. We are given the root of a binary tree. Our goal is to invert the tree, which means that for every node, we swap its left and right children. After this transformation, the entire tree becomes a mirrored version of the original. If you imagine drawing the tree on paper, it would look like it was flipped horizontally. That's why the output looks reversed. Every left becomes right, and every right becomes left. To solve this, we'll use a recursive approach. First, we check if the current node is null. If it is, we return null because there's nothing to flip. Next, we invert the left subtree using recursion. Then, we invert the right subtree the same way. After both sides are processed, we swap them. So the left becomes the right, and the right becomes the left. Finally, we return the current node with its children now swapped. This recursive pattern is called Postorder traversal, where we handle the child nodes before handling the current one. Let's walk through how the code works. We start with a function that takes in the root node of the binary tree and returns the root of the inverted tree. If the root is null, we return null. That's our base case. Then, we recursively call the same function on the left child and the right child. These calls return the inverted left and right subtrees. Once we have both results, we swap them, so the right subtree becomes the new left, and the left subtree becomes the new right. After swapping, we return the current node, which now has its children flipped. This return value is used by the parent node's recursion, and this continues all the way up the tree. In terms of performance, the time complexity is O of n, where n is the number of nodes in the tree. That's because we visit each node once. The space complexity is also O of n in the worst case because of the recursive call stack, especially if the tree is very deep or skewed. The main takeaway from this problem is that recursion is a powerful tool when working with trees. We use postorder traversal to process children before the current node. By simply swapping the left and right children at every level, we can invert the entire tree. This problem is often asked in interviews because it's simple to understand but teaches core recursive thinking. And that's how you solve LeetCode 226, Invert Binary Tree. I hope you guys found this helpful. Thank you for watching, and let's keep learning.